Hello again everyone, welcome back to ptet.chemistry channel. So this is a tutorial. This is on work 1, redox changes for the combined science or the foundation science curriculum, of which I am only teaching the chemistry bits. Okay, so in this first question we are identifying the physical changes. This is part of the statement in the syllabus that it asks candidates or students to be able to differentiate, to distinguish between physical change and also chemical change. So physical change, there is no change in the chemical composition because you are not forming a new substance, you are not breaking all bonds, you are just changing the physical appearance. These are usually change of states of matter. This is basically your kinetic particle theory from your states of matter, interconversion between solid, liquid to gas, and back and forth. All right. So melting ice to form water, that is just your solid ice going to liquid water. That is definitely physical change. Boiling water to form steam, liquid water to form water vapor. That's definitely physical change there. In terms of reaction number 2, this is chemical change. Because hydrogen burns in oxygen or hydrogen combusts in oxygen. So burning hydrogen is the same as combusting or combustion of hydrogen in oxygen, and you will get water. And to balance the equations, you have 2H2 to give you 2H2O. That's why this is 2:1 there. And the formula of these molecules, diatomic molecule, 2 atoms bonded together, and then this is a compound containing 2 or more elements bonded together. Each of these are in the year 9 covalent bonding topic, where you need to know how to draw the dot and cross for each one. This is definitely a chemical change there for number 2, so it's not a physical change. For statement number 3 or reaction number 3, sodium to water is actually part of your year 9 chemical reactions under chemical formula. I identified 3 or 4 general chemical reactions in your lesson notes in the lecture tutorials back then, I think a few topics ago, under chemical formula. So we have sodium, this is the element sodium. When you add it to water, you get sodium hydroxide, which is the metal hydroxide, group 1 metal, and a plus ions, and you get hydroxide ion. This is as stated in the chemical formula as part of year 9 chemical formula. All right, and you get hydrogen gas, which is a diatomic molecule. We balance equations. We get 2 of that. Actually, we get 1H2, and we will have 2 hydrogen plus 2 hydrogen give us 4 hydrogen. 2 sodium, left and right, 2 oxygens, so 2 oxygen there. This equation is balanced, but of course that is a chemical change because the sodium is no longer sodium, the water is no longer water. There's a change in chemical composition. Chemical change is not physical change there, so only 1 and 4 are correct. Question 2, which list contains only chemical changes? If the previous question was asking you what are physical changes, here is asking you what are chemical changes. If we look at melting, evaporating, okay, so not dissolving, but melting and evaporation. Melting is solid going to liquid. Evaporation is liquid going to gas, but evaporation is not boiling. It can take place on any from the surface at any temperature. You don't have to be boiling. Just like your wet laundry can dry on a hot day because of evaporation, not because of boiling. So these are physical changes. And how do I know that? Because these are change of state. When you change your state of matter from one form to another, that is going to be physical change there. So A cannot be the answer because only chemical change. All right. So if I can find chemical change if I can find physical change in there, meaning to say change of state of matter, that means it cannot be the answer. All right. What else do I have? I have boiling and condensation, which is your physical change. So in this kind of question, you don't even need to have done all these weird stuff that you haven't heard of, but eventually you will have done it by the end of your year 11 combined science curriculum. But then we can cross out what is impossible, because this thing which I have circled, they are change of state of matter. They have what you call physical changes. Therefore, they cannot be the answer. By elimination, there's only one answer there. Question 3. In which change is chromium 2 oxide? So this Roman numeral there, Chromium is this element with symbol Cr. I think from your periodic table, if you look at atomic number, which is proton number, chromium is element number 24 in the periodic table. So it's got atomic number 24 in the periodic table. And then got the symbol Cr. Chromium 2, there's chromium 2 plus, the oxide is O2 minus. We look at the charges. This is like what we call valency, which is the combining power coming from the charges. Then what we do is we crisscross the valency, and then this can be simplified further. You divide by the smallest number. The smallest number is 2. Therefore, we get the simplest ratio of 1:1. You get 1 chromium 2 plus, you get 1 O2 minus, the formula is CrO. These are not required to be done as a working in this question. This is just a recap of your year 9 chemical formula. So if you know you have done year 9 chemistry, this is something that any year 9 students will be able to do. That is your starting material, chromium 2 oxide. You want to undergo reduction, so reduce, undergo reductions. So we know that reduction is loss of oxygen. So where do you lose oxygen? Well, let's identify one by one. When you look at option A, this has got no oxygen, and therefore going from CrO to Cr, you have lose oxygen. So that means that is your reduction, which means A must be our answer. How about B? You got 1 chromium, you have 1 chromium. You got 1 oxygen, you got 1 oxygen for 1 chromium. You have got 3 oxygen, and this is also for 1 chromium because the number at the bottom there is not showing. So this is 3 oxygen per 1 chromium. So this is going to be oxidation B there, which cannot be the answer. Okay, if we look at option C, 1 chromium and 1 chromium, but 1 oxygen become 2 oxygen. So this is CrO gains oxygen to give you CrO2. This is going to be your oxidation. Again, cannot be the answer. How about the last bit? We have, this is a bit tricky because you got 2 there. Because you've got 2 chromium, so therefore you have 3 oxygen divided by 2 chromium. You got 1.5 oxygen for 1 chromium. So you go from 1 oxygen for 1 chromium going to 1.5 oxygen for 1 chromium. That is going to be gain of oxygen. So gain of oxygen is going to be oxidation there. Okay, which means D cannot be the answer. A is definitely our best answer, where you have loss of oxygen for each chromium. Question 4, we have reaction between magnesium and carbon dioxide. So the magnesium has gained oxygen. So the magnesium has gained oxygen in order to form MgO. Just now, you have no oxygen. Now you have oxygen. So therefore, magnesium has been oxidized. How about the other one? When we look at what happened to CO2, the CO2 becomes carbon without any oxygen. So what has happened is the CO2 loses the oxygen. Not just one oxygen, but it loses all of the oxygen, and it's just left with carbon as an element. So loss of oxygen is what you call reduction. When you have both oxidation and reduction in the same reaction happening at the same time, happening simultaneously, that is called a redox reaction. This is a redox change topic. So identify a redox reaction by looking at gaining and losing of oxygen. Well, what do we know? Carbon is oxidized. Well, carbon is reduced. Carbon is reduced. Carbon in carbon dioxide is reduced. So that one is wrong because what happened in this reaction? Magnesium is reduced. Magnesium gains oxygen. So magnesium undergo oxidation. That is wrong. Neither means nothing. Not any of them happened. That is wrong because we can clearly see there is oxidation and reduction. The carbon gets reduced. The carbon in carbon dioxide gets reduced. The carbon in carbon dioxide loses oxygen. The carbon in carbon dioxide, meaning carbon dioxide loses oxygen, carbon dioxide get reduced. That is correct. This is our best answer there. In this next question, question 5, we know that this is our classic case study. The fact that it's about manufacture of iron, it actually shouldn't just be iron oxide. It actually should be iron 3 oxide. In fact, we know it because we have seen this case study a couple of times. It's actually Fe2O3 plus CO, giving you Fe plus CO2. Your case study says you have to balance equation. So we have a 2 in front of ions, and we know that it's not 2, we know it's 3 and 3 in order to balance the equation. Not that they ask you for this, you don't get any marks here. You are asked on which substance has been reduced. Okay, reduction is loss of oxygen. We know it that this Fe2O3 become Fe, so the Fe2O3, basically the iron 3 oxide, loses oxygen to form Fe, and loss of oxygen is reduction. This is basically stating everything very clearly, so therefore Fe2O3 gets reduced. And what is the reducing agent? The CO, the carbon monoxide, is the reducing agent, because if you are a killer, you kill someone. If you are a reducing agent, you reduce the other substance. You reduce the Fe2O3 by stealing away the oxygen. You steal away the oxygen and you make the Fe2O3 lose the oxygen. And when the Fe2O3 loses the oxygen, the Fe2O3 gets reduced. Okay? Next question, we have aluminium. So aluminium oxide is going to be Al3 plus and O2 minus. We know that in terms of formula, we look at the charges, which give us the valency. The charges on the oxide is 2 minus, and we get 2 there. And then when we crisscross, we will get how many of each ion. This is about how many of the ions you need. Well, you have 2 of that Al3 plus, and you have 3 of that O2 minus on the right hand side. Altogether, your formula is Al2O3, which is what they have given you here. Reacting with magnesium, giving aluminium and magnesium oxide. Of course, magnesium oxide is Mg2 plus O2 minus. The 2:2, simplest ratio is 1:1, because you simplify from 2:2, crisscross. Alright. This is very similar to the iron 3 oxide example, but this is about why the Al2O3 get reduced. If you can imagine, you got oxygen, and here you have no oxygen. So going from that Al2O3 going to Al, therefore the Al2O3 loses oxygen, and loss of oxygen is going to be reduction. And that is what we have to explain. We have to use this equation. So the Al2O3 loses oxygen, and loss of oxygen is reduction. It's basically stating the definition stated in the syllabus. Now the next one is a calculation question. We know that this is to do with reacting masses. This is a year 9 concept that I have covered in a series of lecture tutorials, as well as in a series of work associated with the lecture tutorials on reacting masses. If you are not comfortable with any of these calculations, you must be able to go back to these lecture tutorials and redo all of those examples until you're familiar. Now you want the mass of aluminium. This is aluminium, and then you want aluminium oxide. Aluminium oxide is that. So from the equations, I write 1 Al2O3, because there's no number in front, it means there's one of it, and I got 2 Al. So 1 Al2O3 give me 2 Al. I don't care about any other thing. I'm just comparing two things there. Now my job really is find out the MR. If I have the MR is defined as the sum of all the relative atomic masses. In the periodic table, aluminium is element number 13, and then we look at relative atomic mass. This is as stated in the periodic table. All of you should be able to do this and get this information from the periodic table. Just like oxygen is 8 and 16, so 16 is like that. You don't need to write this down here as you're working, because you read this from the periodic table. But you do need this MR of Al2O3 in your working. So there's 2 of the aluminium, 2 times 27 times 2, because you got 2 aluminium. Sum up. Sum up means you total up, or you add up all the relative atomic masses. I've got 3 oxygen atoms, so 3 times 16 there. So what I get is 102. Now we know that this is reacting masses, because this topic was called reacting masses. This is MR. MR is for 1 unit. For 1 unit. So after that, I have my reacting masses there. I should really move my working around so that everything looks a bit clearer. Let me just spend some time moving this around. So remember, the MR is always for 1 unit, it's never for 2 units, okay? So if I just change that color to green. Okay, now we're ready to compare these reacting masses. 1 Al2O3 giving me 2 aluminium. If I have the reacting masses, I have 1 times 102. This is 102 gram because I have 1 of it. I have 2 units of aluminium, so there's 2 times 27 because 1 aluminium has a mass of 27 gram. So 2 units because from the balance equation, 2 times 27, that is 54 gram. So 102 gram of this will give me 54 gram of that. If I have 25.5 gram of aluminium oxide, read the question, what is the mass of aluminium? Let this be X. So you do cross multiply. I'm going to continue my working down there because I've got all the space in the world. So 102 times X is equal to 25.5 multiplied by 54. So X equal to 25.5 times 54 divided by 102. Again, this is your primary school or your lower secondary mathematics. It's about rearranging numbers, rearranging question. This is the unit of mass because there's the mass of aluminium that you can get from this much mass of Al2O3. So there's 13.5 gram there. The unit is already started there, so I don't need to have the unit, but in my working I should always have the unit there. Alright, so really that's the end of this tutorial of work 1 associated with redox changes. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel and follow me at ptet.chemistry. That's at ptet.chemistry on Facebook, Instagram, Twitter, as well as Telegram to get connected. I'll see you in the next tutorial video.